Yo, hope you guys are well. This is my 9:40-ish face, not entertained. Okay? And there might be noise outside, but disregard it. It's not the dogs this time. I have no idea what the heck's going on. But yeah. All right. I hope you guys are well. All right. So today I promised you guys a video. It's gonna be on a foil review. Okay, but in the context of algebra 2. So the main topics are complex conjugates and difference of squares. Okay. Okay, so yeah, what is FOIL exactly? Okay, so I've mentioned this a few times in class. FOIL is not a math, it's not really a math topic, but it's a mnemonic. Okay, so a memory aid to talk about this math topic, just like the special case of distributive property. Okay, so when I say special case, it's just saying basically like when you have you're multiplying two binomials. So basically there's a number here, plus or minus a number here, and then times a number here, plus or minus a number here. So it's like a 2 by 2 case. All right. So basically this FOIL thing is supposed to be the F here, right? That means the first terms of the of each factor, right? That's the F. And then the outer terms, so that's like, and then the inner here. So the O and the I, it's kind of like you have to look at both of them together because otherwise it wouldn't make sense. The outer is like on the outside, the inner is inside. And then lastly, it's the last means the last two terms here, okay? L, okay? A better way of thinking about this is, like I said, the special case of distributive property, right? So, you know, I was joking in class that this is kind of like, think about this as like Oprah Winfrey, okay? And then I haven't really watched any of her like shows or anything, but I know that like in these talk show hosts, I've seen something, they're like memes where like, oh, everybody gets one, right? So basically what it is that um every term not every yeah. So you basically every term in the second factor gets this first guy, okay? And then also every term in the second factor gets the second guy, okay? And so, and by get, I mean by you just multiply those, okay? And then finally you add all of them up, okay? It might be better to think of it like this because then you can generalize this to higher terms. So like basically if I gave you something like this, xy plus yz plus w, and then like y minus z plus w plus l, something, just making these things up, right? So then you can kind of, you can apply this distributive property like this, right? So anyways, so here, if you count this, there's 3 terms here, 1, 2, 3, and then there's 1, 2, 3, 4 terms here. So that means that each, all the 4 terms get the first guy, the second guy, and the third guy. So if you want to actually do that and you distribute this out, there's going to be 3 times 4, which is equal to 12 total factors, okay? And then, you know, when you combine like terms, it might collapse down to less, but yeah, think of it like that. Okay, I rambled on for a while here. All right, so here, yeah, that's basically it. Okay, so now FOIL in the context of this thing called complex conjugates, okay? So complex conjugates, this is just a fancy way of saying it's a pair of numbers, okay? And the pair of numbers, of complex numbers that, so basically anything that looks like this, okay? So that's a complex number, okay? And this thing's complex conjugate is basically, you take the same A, put it here, and then you take the negative version of this B, so you just negative BI here, okay? So when people talk about complex conjugates, they're talking about these 2 pairs, okay? All right, so for example, if I told you A was like 5, so if I said A equals 5 and B is equal to 7, then that means that the complex number I'm referring to here is, what am I doing? I'm tired. 5 plus 7i and 5 minus 7i, okay? So here, yeah, so here this minus part because of that, okay? All right, so now there's a special property about these pairs. If you actually multiply these, what that's going to do is it's actually going to like kill or clear the imaginary terms. And what this is going to turn out after you distribute, or aka you FOIL this out, right, is it's going to be a nice real number. So there's no imaginary parts. Okay, so I know some of my middle school students found me and stuff like that, which is good. So if you don't have to understand everything, but I personally would teach this in middle school, right? But like just give you guys this when doing like a FOIL lesson, and then instead of, because they usually use X here, but you could think of this as I and then just like simplify, and then you could kind of add this bit like I squared is equal to -1 to simplify further. But yeah, okay, I'm rambling. Anyway, so yeah, so complex conjugate. So this is a complex conjugate. Another one, we could do -3 plus 4i, and its complex conjugate would be its conjugate pair would be -3 minus 4i. Okay, and if you multiply these, like I said, we're going to do that right now. So we're gonna work on these two right now. Okay, when you multiply them, you're going to get this clear, nice number. So here, we're going to do the f terms. So this is the first, 5 times 5 is 25. 5 times -7i, that's going to be -35i. And then 7i times 5, that's going to be 35i. And then 7i times -7i minus 7i, same thing. Think of it like that. Plus -7i, okay, for those listening. So 7i times -7i, it's going to be -49i squared, okay? And then you're going to notice because that these inner terms are going to cancel out. Okay, so what's left is 25 minus 49 I squared. But before I said that I squared, you should see my previous video, is equal to -1. So you make that substitution here. So that's like saying -49 times -1 like this, but that's a negative, that's a plus. So it's going to be 25 plus 49. And that's going to be 74. Okay, so once again, what this is saying is that the product of these two complex conjugates is going to give you this number 74. It's low key 74. Okay, so we can do the same thing again right here. It's going to be the f, the outer, inner, last. So I'm just going to do this without drawing these. I didn't even do that. I didn't even finish this up here. So this is the outer. It's the outer term. This is the inner term, and this is the last term. Yeah. Sorry guys if this sounds rushed. I'm super tired and I want to sleep. Okay, but yeah. All right, so I'm not going to do this arrow thing anymore. I'm just going to just distribute. Okay, so first term, -3 times -3, it's going to be 9. -3 times -4i, that's going to be plus 12i. And then positive 4i times -3, that's going to be -12i. Once again, these are going to cancel. And then positive 4i times -4i, that's going to be -16i squared. The inner terms cancel out like this, and then you're just going to get 9 minus 16. I squared, once again, is -1, so you're going to do this, and then you're going to get, it's going to be plus plus, so it's 9 plus 16. In other words, it's 25. Okay, so that means that when you multiply these two, you get 25. You get 25. Okay, this will always happen. Okay, when you have complex conjugate pairs, it's just a property. Okay, now you can make this a little faster, right? If you notice, like, so now this is the next topic, difference of squares. If you think about these as difference of squares, okay. So recall difference of squares. Difference of squares, literally, you're taking the difference. So that means the answer to a subtraction problem of two squares. So square a squared and b squared. Okay, it's commonly used. Okay, a squared minus b squared. So where a and b are some numbers. Okay, so here, when you see this, you could factor this as this. So you just take a minus b and a plus b. Okay. So if you look at this very, very carefully, you might see that here. So here, let me take this general case here. So Control C. Okay, so watch this. All right. So in the general case, so you could think about this as like a third example that we do. All right. So here you do a times a. So this is going to be a squared, and then a times negative bi, which is going to be negative abi, and then bi times a, which is going to be plus abi. All right. Commutative property of multiplication, right? And then bi times negative bi. So that's going to be negative b squared I squared. Okay, and then look at these inner terms. These will cancel out, and you're just going to get a squared minus b squared I squared. But I know this is going to sound a little confusing now because we didn't talk about perfect squares like this in reverse, but this is basically a perfect square, right? Because basically, like you could rewrite this as bi to the power of 2, okay? If this is making sense, right? And yeah, if you want to see why, simplify this. Okay, this literally means take this and multiply with itself 2 times. So it's going to be bi times bi, and you can get back that. Okay, does that make sense? So yeah, you could think about it like this. Okay, and then when you do this, so this is like the theory part of it. Okay, but in practice, if you know that when you have when you have it in a plus bi form like this, for each of them, these inner terms are going to cancel. So that means to do this very fast, all you got to do is multiply the first terms and then the last terms, and then you just add. Okay, so how many examples am I doing? -7 minus 5i. Multiply that with its conjugate pairs, it's -7 plus 5i. So for example, you don't need to FOIL this out entirely. You just multiply these 2 terms, right? It's going to be 49. And then these last terms, that's going to be -25i squared, okay? And I squared, once again, -1, so this is going to be plus 25, and then 49, so then this is going to be 74, okay? You know, I created this example on the spot, but it's funny. This is subconscious thinking again. Like I said, I just tend to gravitate towards certain numbers, and it's the same thing as this. But you can see we just got the same answer for this question, so it's like a good sanity check. Okay. So once again, in practice, you don't do the inner and outer terms. I mean, you do list the inner and outer terms, but here, if you notice the behavior from this, then yeah, it's just faster. Okay? Yeah. Okay. Yeah, this is like super rushed, but it's okay. You're gonna see the good side and the bad side of me, these vids. So yeah, all right. Hopefully this makes some sort of sense, and if not, please ask questions. Okay. All right, guys. Have a good night, and I hope you guys have a good day tomorrow. All right. Peace out.